You want to start the solar rotation lab with the template file, which is this file right here. And you notice that there's several pages here. It's broken down into sections. Tells you what lab number it is, determining solar rotation. Tells you the overall purpose. These things highlighted in the yellow table there are the items that you're going to need to complete this lab. And then there's background information followed by the procedure. And the procedure includes the step-by-step things that you need to complete in order to finish the lab. And then at the end of some labs, not all labs, but of some labs, there are follow-up questions. And you answer these follow-up questions through an online quiz. Now this lab has at the very end several image files. You can see this one has June 22nd in the upper left-hand corner of the image there. And what you're seeing is the face of the sun. And there are lines marked off. There are longitude lines and latitude lines. And if you'll look at A, sunspot A right there, I kind of put a little marker beside it there. That is on a longitude line that is 60 degrees. So it goes up here down to A, and you can see that's negative 60 degrees there at that point. Now there's also sunspot C up here at the top, and sunspot B. You go from A to C. Where's sunspot B? Well, B is off around the other side of the sun here. You can't see it from this image. However, when we go forward to the next day, you can see sunspot B has appeared right there. Okay, so you'll also notice that A has moved and is now at negative 45 degrees. So it went from negative 60 to negative 45 degrees over the span of this June 22nd to June 23rd. And if you look at June 24th at spot A, now it's right here. And that's not quite to negative 30 degrees, so you have to estimate in between the longitude lines exactly what that is. And that's approximately, estimate it to be like 31, 32. Negative 31, negative 32. And then you do that for all of the sunspots throughout all of these images here. Okay, so going back up to the top here, the background information tells you a little bit about sunspots and what's to come. And then when you get to the procedure, it tells you to fill in this data table. And the data table includes sunspot group A, B, C, and all of the dates for all the images are listed there. Negative 60 degrees, negative 45 degrees, those are already entered in for you. And then, if you recall, sunspot group A on June 24th was approximately negative 32 degrees. So you need to fill in the rest of them then. After you fill in this table, oh, by the way, sunspot group B on June 22nd, it wasn't present on the face of the sun, so you just leave that blank. You don't put 0 or anything there because 0 would actually be a legitimate longitude entry. So you just leave it blank, and you'll have fewer entries for group B than you do some of the others. Okay, then we get to the analysis section. It says inspect your reduced data. You should have completed data table 1, which is just kind of what I said. Step 3, determine the number of degrees of longitude that sunspot groups A, B, and C move each day, and record your answers in data table 1.02. So that's this next data table down here, data table 1.02. And the way that you get the entries for this table are you take these 2 days. You see where it says June 22nd, June 23rd there? The difference in longitude between those 2 days. So if you go back up to data table 1, here's June 22nd and June 23rd, and you'll notice that it goes from negative 60 to negative 45. Now the order in which you subtract these is important. You do negative 45 minus negative 60. So let me say that again, negative 45 minus negative 60. Now, what that does is, since you're doing a minus and negative, it makes that 60 a positive. So when you perform the subtraction, you end up with a positive 15 degrees. Now, every one of these entries that you do here are going to be positive values. You'll have positive values because of the way the sunspot direction is going. Also, sunspot group B, you're not going to have an entry for the top one because remember, it was not present on both of those days. It was not present on June 22nd. Okay, after you fill in data table 1.02, then you come down to data table 1.03, and it says after completing data table 1.02, determine the average number of degrees of longitude each sunspot group moves. And you do this by taking the average of each column in data table 1.02. So in other words, you just take the average of everything up here in 1.02, and that's just the sum divided by the number of entries. And you record that down here in data table 1.03. Okay, so that's pretty straightforward. And then step 5 talks about correcting the data. There's a correction that has to be made to the data because of the changing orbital position of the Earth, and you can read all of this information right here. And there's a lot of words there, but the correction is very simple, very straightforward. And after you read that, you should be able to correct your longitudinal rotation and fill in data table 1.04. It's really simple. It's not tricky at all. Then step 6, after completing data table 1.04, you're now ready to determine the rotational period of the sun. Recall that the rotational period is the amount of time required for the sun to rotate once 360 degrees on its axis. The data in the previous table up here is for the number of degrees per day. Okay, so you've got the number of degrees per day in data table 1.04, and what you want to figure out is how many days does it take the sun to rotate 360 degrees. So you take 360 degrees and you divide it by the entry in data table 1.04, and that's what goes in data table 1.05, and that's pretty straightforward. Then for step 7, the values recorded in data table 1.05 represent the rotational period of the sun. So you'll probably have 3 different rotational periods. Hopefully those are somewhere in the 20-something day range. If you've done that, then all that you have to do in order to compute the value that goes in data table 1.06 is average those 3 values. And then as a last step, you need to answer the follow-up questions, and the follow-up questions are here. You will answer these follow-up questions in a quiz that you'll find inside the Canvas course. Okay, there's another file here that I'd like to open up, and let me see if I can find it real fast. This is the Excel file, and you'll notice down at the bottom, down here, there's data. It says data table 1.01. And then the next tab says data table 1.02, and the next tab is 1.03, and then 1.04, and then 1.05, and then 1.06. So all of your data tables are here, and you can switch back and forth between the various data tables by changing these tabs down here at the bottom. So the entries that you put in the data tables could be directly placed into these cells that you see right here. All of these cells need to have entries in them, except perhaps that top one right there where there is no sunspot group B for 22nd of June. Okay, so all of these entries, all of these tables, and all of the entries that you can put in all of these tables need to be put into this Excel spreadsheet, because this, as an online student, is what you're going to turn in. You will submit this file. And you don't have to save it in a PDF form or anything. You just save it as an XLSX file, which is the type of file that it currently is. And you upload that through the Submit Here link that's inside the Canvas course. Okay, so that's how you're going to submit this file, the Excel file, and you're also going to answer the follow-up questions through the quiz that you'll also find in the Canvas course. So I think that pretty much covers everything that you need to know in order to complete this first lab. If you have any questions, you can certainly ask me, but hopefully that's a good enough explanation that most of you can do it. All right, well, have a good day.